Here's our lesson on graphing the tangent function. It follows the section of sine and cosine graphing. So today we are going to learn how do we graph the tangent function and what exactly are those properties that are involved. So if you recall, we used the specific points on the unit circle in graphing sine and cosine, where for cosine we looked at the x coordinates of the unit circle, and then on sine we looked at the y coordinates of the unit circle, and we plotted those accordingly to see what those parent functions look like. For sine and cosine, we specifically chose to work with 5 points that came and sat on the quadrangles, and we made one revolution around the unit circle. So we started at 0 and we rotated 1, 2, 3, 4, and 5 every 90 degrees. We plotted those coordinates and we came up with the sine and cosine function. For the tangent function, we are going to complete one revolution as well, evaluate the tangent on every angle by evaluating the y divided by x, but instead of going in increments of 90 degrees, we are going to do increments of 45 degrees. So we'll start here, go to pi over 4, pi over 2, and so forth. And we're going to populate the answers to that here in this table to the right. This time I went ahead and wrote out our angle measurements in degrees since we practiced doing sine and cosine in radians. So let's go ahead and fill out this table. At angle 0, right over here, we're going to evaluate the tangent of that theta at 0 degrees. So we are going to take the y value and the x value and divide them. So 0 divided by 1 is what we're doing on this first one, and we get a 0. Then we're going to go to 45 degrees and repeat the same thing. This is our x and our y. When we divide the y divided by x, notice they are identical, and when you divide identical numbers, you get a 1. Go to pi over 2. Again, y and x are labeled. Take our y and divide it by our x. And in this case, notice our 1 is being divided by 0. We can't do that, okay? When you can't do that, what I need you guys to do and recognize is that at this angle, our value is what we call undefined, okay? Students tend to mix those two up very easily. So there's one way that I learned, and then a student today taught me another way. But I want you to remember that if you have 1 over 0, think of the 0 is under the division sign. The under, UNDE, will remind you that it's undefined when you're dividing by a 0. Another way a student showed me, it was really cute, if you have a number n, any number n, and you're trying to divide by 0, that spells the word no, no as in not possible. So stop and make sure you note that it is an undefined value. And I'm off my page and I didn't even realize it. So let me shift it over there again. So 1 divided by 0, when the 0 is underneath the division sign, under, UNDE, will lead you to remember that it's undefined. Okay? Over here, it's okay to divide by 1. It's not okay to divide by 0. So don't confuse those two. And the other way that the student said, number divided by 0 spells no. So stop. Make sure you write undefined. Anyhow, if we continue with this process of dividing y divided by x, you are going to get the following values. Actually, you know what I'm going to do is ask you to stop right here, pause, fill these out, and then come back. Okay, so you should have got 0, 1, undefined, -1, and 0. Okay, so what we're going to do is we're going to take those values and we are going to graph them. Now, what happened, well, I'm going to actually work a little backwards when I say that, but you're going to see how the tangent function does have these values on the graph, but I digress. When I created this note-taking guide, if you're using it, I did forget to create a section where we graphed this table of values. So I'm going to bring alongside a graph paper, which you can do the same. And so I'm going to place that right over here to the right of our table so that we are able to do what we're going to do. So as I continue talking about this, here is our x-axis, which will be representing our angles, and the y-axis is going to be the tangent of those angles, the answers we get. Our answers fluctuate between 1 and -1 for our parent graph, so I already counted 2 units up and down for 1 and -1. I counted out 8, labeled 1 revolution of 360, so let's go ahead and split it up, and we will have these labeled as such. Okay. For tangent functions, it's a none. Let's go to period. The period formula is going to change for tangent. For sine and cosine, let me remind you, our period was 2 pi over b. But for tangent, our period is not 2 pi in length. Our period was 180 degrees in length. Okay, so we are not going to use 2 pi, we are going to use pi over our coefficient of b. So let's work that out. Our b is the coefficient of our theta, or our x. So in this case, pi, substitute b with that number, and it's 2. So our period has shrunk. It was a length of pi, now it's shrunk to pi over 2. It got less wide, horizontally compressed. So next thing we need to find are our asymptotes. We cannot graph our asymptotes until we find it algebraically. How are you going to do that? Well, you're going to take the quantity after your trig function, so either 2 theta or 2x, whatever you want. Do not take that because that's your vertical translation. 2x, and we're always going to equal it to the asymptotes of our parent function. Going back again to our parent function, our asymptotes, the ones closer to the origin, let's use these. The asymptotes occurred at -90 degrees and +90 degrees. This right here is our tangent. Our tangent function, and those are asymptotes. You can use these and these, it's no biggie. I'm just choosing the smaller values in our asymptotes. So 90 and -90 in radians is going to be pi over 2 and -pi over 2 if you go negative. So let's go ahead and write that down. And so these numbers will always be positive and negative pi over 2. So let's solve for x. To solve for x, I need to get rid of the 2. The 2 is multiplying by x, so that means I need to divide this side by 2 and divide this side by 2. Now my 2's can cancel out. Now I have a 1x, which is what I was trying to solve for. When you are dividing, this is a stacked fraction. When you have a stacked fraction, you want to multiply by the reciprocal of the denominator. So bring over the numerator, and then you change it by multiplying by the reciprocal of 2. Well, coming over here to the side for space, 2 is the same thing as 2 over 1. So if I want to write the reciprocal of 2, it's going to be 1 over 2. So I simplify, and I get pi over 4. So my asymptotes are going to occur at positive pi over 4 and negative pi over 4. So let's come over here to our graph. I'm going to go to negative pi over 4. I'm going to draw my vertical asymptote at negative pi over 4, at positive pi over 4, okay, so that's 1 period. Remember I told you guys I want at least 2 periods. So if I have a space of 2 between this original, I can just continue that pattern. So every 2 squares, I can add on some more periods. Okay. So now I have 2 periods. I'm going to add 1 more for graphing purposes. And we can do this forever, but I just need you to do at least 2. Okay, don't give me 1, give me 2 or more. So here's 3. But focusing on the original one, okay? So we did our 2 asymptotes. So after you have found your amp, your period, and your asymptotes, you are going to find your midline. Midline is found just like you have been doing all along. Our midline is our vertical translation. Always write it as an equation, y equals -1, because it's a horizontal line, okay? So y equals -1, so I'm going to use my ruler and I'm going to put where that midline is. So here's our midline, right there, okay? So what do? We already got 1, 2, we need 3 more things, and that is our points in between that space. The first point will always be on the center, in the center of those 2 asymptotes at the midline. So you don't come over here and put your dot here. My midline is this right here. So my first dot has to sit on the midline in the middle. So that's going to be right here. So I'm going to put a dot. And I need you to give me what that dot is. So down here, I'm asking you guys to give me the points. Well, the coordinates of that point is going to be 0, comma, -1. 0, comma, -1. So I'm going to come over here. Okay, that's my first point. Let's go find the second point. The second point, stay on your midline. I go halfway between the left and the right point, the left asymptote and the right point. That middle is right here. I know that this point on the left will always go down unless there's a reflection, okay? But right now there's no reflection. It's a +4. So middle, and I'm going to go down 4. 1, 2, 3, 4. I'm going to put that dot. And I'm going to repeat the behavior on this side, but I'm going to go in between up 4. 1, 2, 3, 4. And I'm going to put my dot right there. And I'm going to make my curve. Curve downwards. And I'm going to curve upwards. There you go. And you're done. And we're going to just copy what we did here, here, and here again. This dot goes here. Then 1, 2, 3, 4. Curve down. In between, 1, 2, 3, 4. And curve up. And I do it one more time. Here, and here, and here. And again, don't forget, those points always line up very straight. They look like a line, okay? So curve down and curve upwards. If it was a reflection, if this had been a -4, this middle would have gone up and this middle would have gone down. So your graph would look like this, okay? Now, let's get those other 2 points. This point here was the other one. So you might be asking, well, this is in between 0 and -π/4. How do I find that value? Like, how do I get that? Well, that is in the middle of -π/4. Middle means half. So half of -π/4 is equal to -π/8. So that coordinate there is -π/8, comma, down 5. And if the distance from here to here is -π/8, then the distance from here to here is +π/8. So +π/8, comma, up 3. So there is my third point. And that's it. That's all that's required. So let's practice one more time on how to do the graphing. I want you to pause the video, and I would like you to initiate by finding out your amp, your period, and your asymptotes, and your midline, and then unpause and see if you have followed along and you understand what's going on. So take the time and pause right now, and I'll see you in a second. Okay, so hopefully you really did pause. Our amplitude, don't write down the 3, write down none. For tangent graphs, always none. Period. Don't write down 2 pi. 2 pi belongs to sine and cosine. It's pi divided by b. Our pi is going to be divided by our b. Well, our b, let me write this down in terms of x, for those that prefer x. Okay, so the coefficient of our x, which is our b, is an invisible 1 over 3, so it's 1/3. Stacked fraction, so pi times the reciprocal of 1/3 is now 3 over 1. So we're going to end up with a 3 pi. Okay, so our period is 3 pi long. Let's find our asymptotes. The formula for asymptote says take the quantity after our trig function, so theta over 3, which I'm going to write as x over 3, and we will always set it equal to pi over 2, which are the asymptotes of your original parent function. What do I need to do to isolate my x? Well, I need to get rid of this 3. This 3 is dividing, therefore I need to multiply both sides by 3 so that I can get rid of that x. So 3 pi over 2. Don't do 3 pi over 6. The 3 is only multiplying by pi because that's like saying 3 over 1, okay? So 3 pi over 2. So I'm going to stop there actually a second and go ahead and plot my positive and negative 3 pi over 2. So right now you probably are noticing, well, wait a minute. How can I graph negative 3 pi over 2? I see 3 pi over 2, so let's go ahead and put that in because I see that. But I don't see negative 3 pi over 2. Well, that's okay. Because remember, these graphs go on forever in both directions. So I know that this is positive 3 pi over 2, so negative 3 pi over 2 is probably somewhere around here, right? Well, look at the length of that period, right? About how many squares do you think that is? Well, from here to here is positive 3 pi over 2, and that's 3 squares. So from here to here, if I did draw, I'm going to make it really light, but if I did draw my line, you know, from here to here, that's another 3 squares possibly. So it's a total of 6 squares. So let's count 6 in this direction. 1, 2, 3, 4, 5, 6. So at 9 pi over 2 is where I would draw my other vertical asymptote. Now, if you want to make sure you did that correctly, always check the period, okay? You can check the length of your period to see if you indeed picked the right place, because based on your math here, your period is supposed to be 3 pi long. That's what you told me it was supposed to be. So is it 3 pi long? Well, let's see. It went from 3 pi over 2 all the way to 9 pi over 2. Well, how long is that? Well, let's see. If I subtract this minus this, I'll know the distance. 9 pi over 2 minus 3 pi over 2 will give me 6 pi over 2, which is indeed 3 pi. So I know that I did pick the right place, okay? So there's my asymptote. My other asymptote would be way over here. I can't draw it out, but that's okay. Where's my midline? My midline is y equals -2. So let's place my orange ruler here at y equals -2, because on that line is where I need to put my midpoint between the two asymptotes, which in this case would be right here. And I'm going to go ahead and label that point down here at the bottom, since I'm required to give the 3 points. 3 pi, comma, -2. So far I have 1, 2, 3 characteristics. I need 5, so I got 2 more to go. Let's put this line back here again. There's our midline. The distance between here and here, find the midpoint. My midpoint is right here. But I need to move this where? I need to move it down that coefficient value. 1, 2, 3. I'm going to put that dot right there. I'm going to repeat it. The distance between here and here. There's the midpoint. I need to go up. 1, 2, 3. I'm going to use a ruler to make sure that they line up. They do. So I am able to draw my curve. And let's go a little bit closer to the asymptote. Okay. So there's that. And if I needed to find something on this side, because there's nothing over here, I have some space. This was 3 units away from the asymptote, so my other dot should be right here, 3 units away. And if I go to the middle here and go 1, 2, 3, it matches up with that one right there. So I know it has to go up like that. And I know this side's going to go down. And I'll just make it short just to prove that I know it's going in that direction. But what am I going to show you? Oh, we do need to get the last 2 points, and then we're done. So here is what some students are having issues with. Okay, so right here, this was pretty easy to look up and see that that was 3 pi over 2, and look across over here. So 3 pi over 2 comma -2, that's pretty easy. But what happens when it's not falling on that grid? Okay, so I mean like this one. This one right here, let me use my ruler. If I look up to find the x value, it is falling right in between these two. Okay, the y value, okay, I got that. That's not a problem. That's going to be a -5. So something comma -5 is my point. How do I find that? Well, it's right smack in the dab in the middle. So what I suggest that you always do is go right back over here. Now I know that 1 square is worth pi over 2. But I need to know what is half of a square. What is the distance from here to here? From here to here. Well, what is half of pi over 2? So you're basically going to do what we did back over here when we're looking for halves. Take the half of pi over 2. And the half of pi over 2 is pi over 4. So if you count your squares, if you split your squares in half, that would be pi over 4. So how many fourths does it take to get to this spot? Okay, well from here to here is 1, and from here to here is 2. So let's see how much it takes to get here. So I'm going to count by 2's until I get there. So 2 fourths, 4 fourths, 6 fourths, 8 fourths, and then I'm going to count by 1 because I'm not going to jump to 10 fourths. 8, this is 9 fourths. Okay, so here we're going to put 9 pi over 4. And I want you to see how it works, because if I go from here to here and that's 2 fourths, doesn't 2 fourths reduce to pi over 2? Or 2, 4, 6. 6 fourths. Isn't 6 fourths 3 pi over 2? So notice that if you count by fourths, it better reduce to the ones you do know. So go ahead and try and figure out what this one is. Pause the video, figure it out, and then come back and see. All right, let's count. 2, 4, 6, 8, 10, 12, 14, and then 1, 15 fourths. So 15 pi over 4, comma, positive 1. And there you go. You've got your 5 characteristics, 1, 2, 3, 4, 5. That's what I need you guys to do every single time you are graphing tangent functions. So hopefully that has helped you understand a little bit. And as usual, let me know if I can answer any other questions. Thanks for watching.